All right, mathletes. This is one of my favorite, kind of parts of teaching calculus is where we kind of get through some of the stuff we've done so far, which is really conceptual and fundamental and foundational, and now we're getting into some of the fun stuff, some of the shortcuts and ways to do things that are I think more efficient than what we've been doing. And we found out some important things, right? We know that calculus and the derivative can find us instantaneous rate of change, right? Instantaneous velocity, slope of the tangent line at a given point, which is a big deal, and we do that through our limit definition. So limits was a big part of this, but now we get to a point where we're gonna be able to do all that stuff, but do it in more efficient and I think straightforward ways. And so anyway, I hope you enjoy this, and you earned it. You earned it to get this far. So let's start with the constant rule. So the constant rule, and you may have noticed this before, but if I take the derivative of a constant, like let's say I have, let's just use C. Let's just say I have f of x equals a constant, right? And let's say that I want to find f prime of x using our limit definition. So that would be the limit as h approaches 0, and I'm just going to cut to the chase a little bit, and I'm just going to plug in, if I want to do f of x plus h, well, there's nowhere to plug in x plus h there. So f of x plus h is just c, right? Because there's no variable here. That's a constant. So no matter what that number is, whether it be 5 or negative 10 or 2/3 or negative pi, whatever it is, there's no place to plug in the input. So you're just going to get that constant all the time. All right, and then it's going to be minus f of x, which is also c, all over h, right? So here's a situation where we have a 0 over 0, like c minus c is 0, right? So it's going to be the limit as h approaches 0 of 0 over h. And we've seen some 0 over 0 situations where we can kind of reduce and cancel and things like that. But this is a little different, because if I just have 0 on top and I approach 0, so think about, like, if I plug in numbers for h that are really, really close to 0, it really doesn't matter, because if I do 0 divided by those numbers, I'm always going to get 0, right? So 0 divided by 0.1 is going to be 0. 0 divided by 0.01 is going to be 0. 0 divided by 0.001 is going to be 0, and so forth and so on. And so as we get closer and closer to 0, as long as there's a value on the bottom that's not 0, 0 divided by that value is going to be 0, right? And so this actually comes out to 0, all right? And so, all right, so that's what happens when you take the derivative of a constant, is you just get 0, okay? All right, and here's another way to say it. If f of x is a constant, then f primed of c is going to be 0, okay? And that should say f primed of x. That should say f primed of x there, okay? So if f primed of x is a constant, then f primed of x will equal 0, all right? Or you can say the derivative of a constant. So this is the function in here itself. Remember, this is the operator of the derivative. So the derivative of a constant is 0. Or you can say it like this: constant primed equals 0. So all those mean the same thing. Now, one other way to think of this intuitively, if you think about a constant function, if I have f of x equal a constant, then what that is a horizontal line, right? So it's a horizontal line that goes through wherever c is, right? So let's say c is right here, and so this would be the function, and so that's a horizontal line, and so everywhere on that line the slope is 0, right? So if I find the slope here, it's 0. The slope here is 0. Slope here is 0. Everywhere it's 0, right? And so that's another, that's kind of an intuitive way to think about, if you take the derivative of a constant function, then you always get 0, because the slope is 0 everywhere, right? It's constant. It doesn't go up or down. The function just remains the same. So the rate of change is always 0, right? No matter what x is, the output stays the same. So there's 0 rate of change. All right. So That makes this pretty simple. So if I say find the derivative of f of x and f of x is 8, then f primed of x is going to be 0. That's all there is to it. So that's our answer. So if you take the derivative of a constant, you always get 0. All right, so why don't you try 3.11 here, checkpoint 3.11, and find the derivative of g of x, which is equal to -3. So find g primed of x. All right, and if you got 0, well done. That's it.